So hello everyone and welcome to yet another problem from Geeks for Geeks. It says remove k digits. Now the problem is pretty much simple, but the intuition, the logic behind it is quite difficult to come up. So it's not very difficult, but yeah, stay with me. The problem says given a non-negative integer s represented as a string and an integer k, remove exactly k digits from string so that the resulting number is smallest possible, uh, while maintaining the relative ordering of the remaining digits. Note, there is also note that the resulting number must contain all the leading zeros. If the resulting number is an empty string, after the removal, return 0. That is a pretty sweet thing. Now we have few examples. One of this example is this one, where we have to remove 3 digits from this one, and we have this string. So they have went ahead and choose to remove this, and this. So 4 3 and this one 5, which will left it with 2043, which is the smallest possible number which you can think. Similar goes with this, but only thing is here they are removing 5 numbers. So how are we going to do this? How are we going to solve this one? So one quick thing which can come into your mind is that hey, why don't we go ahead and check all possible solution? So that's possible, but for all possible solution you have to choose whether I wanted to use this or not, and that would go up to 2 to power k combinations. Not to mention 2 to power not k but n multiplied by k, because you are trying k times everything. So yeah, this is not very efficient solution. So how are we going to do this? How are we going to solve this one? One thing which comes into your mind is, hey, why don't you go ahead and remove the starting numbers, which would be maximum. So here in this case they have removed 4 3, which were starting numbers, which were maximum, but they also removed 5. So we cannot just rely upon the starting numbers, and we cannot just rely upon the maximum numbers. Like if 9 exists or if 8 exists, we cannot just go ahead and blindly remove them. So we have to understand few things before we going. We have to understand that hey, what number shall I call greater, or it's a larger number. So I want you to understand this simple example. I'll not take this larger number, which would be having multiple digits. I'll just take 2 digits for now, which are 6 and 9. There are only 2 combinations. One is 69 and one is 96 and 69. So I want you to understand which one is greater and which one is smaller number here. Pretty obvious. You'll say that hey, this is smaller and this is larger. Interesting. I'll add one more number here. 6 6 9 and 9 6 6. Again I have 6 9 6, and all those combinations which can happen. I guess I have covered the combinations, but now you can say that hey, within the priority wise, this is the smallest, this is the largest, and this is in midway. Yeah. So how do you get with this solution? You got this solution by understanding hey, the number first, I'm checking the first number. So maximum significant bit I'm checking, or the first number. I'll keep it simple. First number checking. Then if it is small or if it is greater, I'll just go ahead and say it's a greater one. In this case, you have chose these numbers and you saw 9. Oh, 9 is greater from all. So this is largest. Then you went ahead to the next number. Next from first. So if you choose the 0th index, then you chose the 1 index. And then you considered that hey, from this, which is the greater one? And then you choose that. Again, we don't want greater one, we want smaller numbers. So what our agenda should be? Our agenda should be smaller number should come first, then or shall I say smallest number should come first, then smaller, then small, and then medium. and if you have any numbers you can get to bigger numbers. Quite obvious, right? So 1 2 3 4 is a smaller number rather than 3 2 1 4. Obviously, this is our idea is. So I'll just take the idea that hey, smaller number should come first. If a non-smaller number comes first, then remove. That is it. That is the gist of all the problem. That is what you wanted to do now. I repeat myself again. If you see any non-smaller number, and then you have to go remove that. So you want in this fashion. You wanted to make it in this fashion. How are you going to do that? Cool. I'll take back my example. Let's get this example back. Okay. This is the thing. So I have 4. Then I have seen 3. Does this fit into our perception? Does this fit into our perception that say smaller number should come first? But no, 4 came first, which is not small. So I have to remove this 4. Cool. I have removed this 4 first. Then my number is 3. Then my next number is 2. Is smaller number coming first? No, 3 is not small. So I'll remove this 3 as well. Next, I'll go ahead and I'll see 2 and 5. 2 and 5. Yeah, 2 and 5. These are pretty good because 2 is small and 2 is coming first. Nice. Next, I'm coming up with 0. No, this won't happen because 5 is not small and it's coming first. So I have to go ahead and remove 5. And now I'm done with 3 removals right here, and they were asking me for 3 removals. Cool. I would just copy this as it is. So my number would be 2 0 4 3, and that is what they are expecting, and that is how we solve this problem. But again, we mentioned it. How are we going to track this thing? How are we going to take this? Shall I every time go ahead and do I and I plus 1? And what if my small number breaks over here? And what if k is greater? K is greater in the sense that hey, I have ascending order, but still I have to remove few elements. What should I do? See, the best thing is to go ahead and do not reinvent the wheel. Use the existing data structures what you have, and that's how you outshine yourself within an interview as well. So first of all, what we have to do is we have to use, and this is very similar resemblance with the data structure as stack, where you check the previous element and then you pop it or push it based upon what is present. So what I'll do is I'll use a stack of integer, or not integer, character by the way, because it's a character array. Still they are integer numbers, but I'll just use characters here. So I'll just keep name stack, new stack. Cool. So I have this stack. First of all, I'll check that hey, if k is greater than s dot length. So this means that hey, I can just wipe out the entire array. So I'll just return 0 in this case because that's what they demand. So this was a clean flush. Now what I wanted to do here is I want to do the step 1, which is build the stack. I wanted to build stack, and meanwhile I'll do operations within the stack as well. So just understand now. I'm taking one by one elements from the stack as 0, as less than s dot length, I plus plus. Okay, I plus plus. So get a character. I'll be where ch is equal to s dot character at this position I, and this would be okay. I'll just use character only. Now while I wanted to check that, okay, first of all I'll take if. Okay, what I wanted to do here is I wanted to check this thing. This thing is smaller number should come first. So what is my smaller number? Smaller number or first number is the thing which is already within the stack. So stack dot peak, which is the first element or the prior number, if it is greater than current digit ch, or I'll say not ch, I'll say current digit. That makes better sense. So if it is in the current digit, remove the stack item or remove the previous item. One and the same, previous item is within the stack, and I will remove this. So stack dot pop. But wait a second, I wanted to check first that stack is empty or not. Stack dot is empty. So if it is not empty, then only I'm going to do this operation. Cool. Makes sense. Interesting. Now when stack is not empty, then only I'm going to do this operation. Pretty much good. But again, if I am able to remove any number, then only I'm going to do this. So k should be greater than 0. If k is equal to 0, then I cannot remove anything, or I cannot pop anything. And meanwhile, if I'm removing anything, I'll just do k minus minus. Am I going to do this one time or multiple times? No, multiple times. Do it while. Cool. So far so good. It seems nice. We have removed this, and now I'm sure that my previous elements, or my previous element is the smallest. Now I'm going to put myself in. Put myself means put the current element in. So stack dot push the current element. Nice. Now it can happen. Tell me that it can happen that we have maintained the array we have created, but still k is greater than 0. We can remove, or I would say we have scope to remove more. We have scope to remove more, and hence what we'll do is we'll do k is greater than 0 and remove what all elements were within the stack. Stack dot pop and k minus minus. Yeah, this makes sense. Okay, the classic example, if you want, the string can be a sorted array. So in this case 1 2 3 4 5, and k is still as 2, and k is still as 2. So here you wanted the last two elements to pop out. That's how we are going. And if you check stack with any system.out.println over here, you will see only sorted items here, because we are pushing in this fashion, right? Smallest then smaller, and this is what a sorted items they are. Now ultimately what you want to do is build the result. What they are expecting from the result, they don't want leading zeros, and if the string is empty, they want to return just 0. So we wanted to take items from the stack and append it. So I'm building a string, so the better data structure is string builder. sp is equal to new string builder. Okay, and I'll say while, okay, what's happening, while stack dot is empty, sp dot append stack dot pop. Cool. But I'm taking elements out of stack. That means I'm getting the elements in the reverse order. Why? Because stack's property is to last in first out, so it will be reverse order. So I'll do sp dot reverse. Cool. Now I have in a good order, but I wanted to remove leading zeros. So these are very minor sanitizations we need to do, but yeah, what's harm in that? So I'll do it anyways. I'll just use while loop here as well. Int I is equal to 0, while I is less than sp dot length, and what I'll say is sp dot character at I is 0. That means I'm seeing 0 at the starts, so I would just do plus plus, and the moment I'm not seeing 0, I'll break out of the loop. And I wanted to just take a substring of this. So sp is equal to sp dot substring from I to the rest of the characters, rest of the length. So this would remove the leading zeros. Now return. Now maybe it can happen that, hey, my while doing this my string is empty, so I need to check that as well. Return sp.length or length. Okay, I'll do length only, 0, then return this one, else just return sp.toString. Let's compile this one. Okay, what is this? They don't have anything like this. Incompatible string cannot be converted into. Okay, they want a string. Okay, my bad. So I'll just have a result there, because substring gives us a string, not not a string builder. So cool. We have passed the sample test case. Let's submit this for the rest of the test cases as well. And yeah, excellent. It passed rest all the test cases. This was a classic problem. Don't worry if you didn't got it in the initial go, but it was a good one. Time complexity and space, we added that, and it follows the topic as stack, greedy, and deque. We mostly did it with a stack, but if you wanted to know more about greedy, deque, and solutions, click the video on your right, and I'll see you in the next one.